Okay, so this video is all about partial fractions and trying to explain the various scenarios you'll get involving partial fractions, why we use them, and what we can do with them after we have split things into partial fractions. Well, the first obvious reason why we use them is if, say, we had these three things added together, which would be kind of in your C3 exam, simplify these things. If we put all these together, I would end up with, this is the same as 11x squared plus 14x plus 5 all over x plus 1 squared 2x plus 1. So we can do that, we could put that together in that form to make it look like the thing on the right hand side. But what if we were given this thing on the right hand side and we're asked to split it into this form, where we have a constant over linear factors. So a linear factor means that we don't have x squareds and things on the bottom. We have an x plus 1 or something where the power of x is the 1 all squared, perhaps, like we have here. This problem here, if given, would actually be a repeated linear factor problem, which you'll learn about in a second. But the reason why I may want to put this back into partial fraction form is that I could then integrate these things, or I could use binomial expansion on these things, which otherwise I wouldn't be able to do if it was in this form. So let's start off with the most basic example of how we would do this. What we're doing is we're taking this thing here, and we're saying that this is the equivalent of a constant a over that first factor in brackets here. So if we were given an expanded form, like x squared plus 5x plus 4, we would need to split it up into brackets like so, plus another constant b over x plus 4. I know that this will always turn out in this form. Now to find a and b, that's the trick. And what we need to do is we need to make the denominator the same here and here as it is in here. And that way I can compare the numerators of both sides, and then I can start forming equations to find a and b. So this thing here is the same as a. Well, what's missing from a? It's missing this x plus 4. So x plus 4 over x plus 1, x plus 4. And the b is missing an x plus 1. X plus 1. Remember, if I times the top, I need to times the bottom as well. This means I can put them together, and I have ax plus 4 plus b x plus 1, all divided by x plus 1, x plus 4. So remember, this is 2x plus 11 over x plus 1, x plus 4 on the left hand side. So since the denominators are the same, I can then very easily say that the numerators must be the same. So I can forget this stuff on the bottom for now, and I can say this. So I'm at this stage. I'm trying to find a and b. So the way to do that would be to substitute in values of x to get rid of, say, one of these brackets and then isolate the b or a. So I'll start by saying perhaps let x equal minus 4, and this will get rid of this bracket here. So I do x equals minus 4 on the left hand side. 2 times minus 4 plus 11 is the same as a, which goes to 0, plus b minus 4 plus 1. So this gives me minus 8 plus 11, which is 3, is the same as a times 0 is 0, minus 4 plus 1 is minus 3b. So therefore, b must equal minus 1. Similarly, let's get rid of the other bracket this time. Let x equal minus 1. Implies 2 times minus 1 on the left hand side plus 11. It's the same as a minus 1 plus 4 plus b times 0, which is the whole point, because I'm trying to get rid of b and isolate a. So I get minus 2 plus 11, which gives me 9, is the same as 3a, implies a must equal 3 then. So my finished form is that 2x plus 11 over x plus 1, x plus 4 is the same as 3 over x plus 1, because a is 3, minus, because b is minus 1, 1 over x plus 4. That's that first example done. It's been put into partial fractions. Let's do it again, except this time, how do we keep that thing there? Okay. So, except this time, I've got 3 linear factors, and maybe this time I can use binomial expansion on it, or integrate it, perhaps. So it doesn't matter how many linear factors you've got, I can still split it up into that number. So this is going to be a over x plus b over x minus 1 plus c over 2x plus 1, and that would keep going as long as I keep having linear factors on the bottom. Right, so with a bit of experience, I can skip that step of making the denominators all the same here, and I can just write this top part out. 6x squared plus 5x minus 2 is the same as a, well, what's missing from a's denominator? Well, x minus 1 is missing and 2x plus 1 is missing. Yeah? Plus b, what's missing from b? Well, x is missing and 2x plus 1 is missing. And c, x is missing and x minus 1 is missing. Yeah? So now I'm at that step. Again, I'm trying to get rid of brackets. So to get rid of this bracket, say, and this one, I'm going to let x equals 1. Let x equal 1 implies 6 times 1 squared plus 5 times 1 minus 2 on the left-hand side. Don't even need to write this because this goes. Equals b 1, 2 times 1 plus 1. And then the c will go as well. So this gives me 6 plus 5 is 11 minus 2 is 9. It's the same as 1 times b. And then in the bracket there, that's 2 plus 1 is 3, so 3b. So b equals 3. Then I'll let x equal something else to get rid of it. So let's x equals 0 to get rid of this one and this one, to isolate a. So therefore what I get is, I get 6 times 0 plus 5 times 0 minus 2 on the left hand side. My a, 0 minus 1, 2 times 0 plus 1, and the b's and c's disappear. So that means a must be 2. And then again, let's isolate another. Let x equal minus a half this time, to get rid of this one and this one, to isolate c. So I get 6 times minus a half squared plus 5 times minus a half minus 2 is the same as just the c value this time. So c minus a half minus 1 is minus 3 over 2. So I'll get that in the calculator, so I can't bother to do it, because in the exam you can get that. Minus 0.5 squared times 6 plus minus 5 over 2 minus 2 gives me minus 3, and then I get c minus a half times minus 3 over 2 is 3 over 4, implies 3 over 4c, implies c then must equal minus 4. minus 3 divided by 3 over 4 is minus 4. Okay, so what I do is I start from where I began. Well, I go back to where I started, sorry. And I can say then that 6x squared plus 5x minus 2 over x, x minus 1, 2x plus 1 is the same as, well, a is 2 over x plus b, which is 3 over x minus 1, minus 4 over 2x plus 1. Yeah? And that's my final answer in that case. And then what I can do is, let's integrate it now. So let's say the question said, integrate this whole thing with respect to dx. Some of you haven't learned integration yet for this kind of thing. But why not show you something? So if I integrate both sides with respect to x, this would give me 2 log mod x plus 3 log x minus 1 mod minus 4 log, put that on a new line, minus 4 log 2x plus 1, but that would integrate to 2, so that would become 2 log 2x plus 1 plus c. You're not going to know how I did that yet, but do you see I could very, very quickly integrate this, whereas integrating this by itself would be an absolute nightmare. Okay? So, another case we have here is the repeated linear factors case. So this is where I have a squared, so a bracket squared, a factor squared. I can't just immediately assume that this is going to be a over x plus 1 all squared plus b over x minus 1. No. If you work it out, what you'll get is that this is the same as a over x plus 1 plus b over x plus 1 squared plus c over x minus 1. So you have to, every time, start from the order 1, 2 until you get to it. So if it's x plus 1 to the power 4, I'll have a over x plus 1 plus b over x plus 1 all squared plus c over x plus 1 all cubed plus d over x plus 1 all to the power 4. Okay? So, in this scenario, again, I'm going to forget the numerator. I'm going to go minus x squared, so the denominator is the same. I'm going to say, what's missing from a? Well, just one x plus 1 is missing from a and an x minus 1. Plus b, only the x minus 1 is missing. And plus c, x plus 1 squared is the only thing that's missing. So you have to be really careful about what's missing from the denominators here to make it look like that. Okay? So once it's in that stage, once again, I can make my let x equal to get rid of brackets. So let x equal minus 1 to start with, to get rid of that bracket and that bracket. I'm going to continue this on the next video.